proceed. Previous knowledge. What did we learn yesterday? Who can remind us what we learned yesterday?
Light.
Okay, yes, we dealt with light. Okay, what are the things about light we dealt with?
Um, so we learned about the sources of light.
Okay.
Types of light, many more.
Types of light.
Then
Luminous and non-luminous objects.
and non-luminous. Yes, I also
Luminous.
learned about mediums through which light can pass through. That's the transparent, translucent, and opaque.
Yeah.
Yes.
Types of reflection.
Okay, very, very good. Very, very good. So before we go, let's just take some questions on it and then let's practice what we did yesterday. Let's go to the first question. They will not really do a reflection of light, but we'll just deal with the basic questions that pop up with the exam. You are going to be asking questions based on what we have done. So, I think it's from jump off. I said you should attempt question 19. Question 19. Here it is.
So can you zoom it into question 19?
Yeah. Can we see now? 19. What's the answer there for 19? Okay, let me read it out just in case you might not be seeing it very clearly. It says the total eclipse of the sun occurs when the dash A is it the earth is between the moon and the sun. B, the sun is between the moon and the earth. C, the moon is between the sun and the earth. D,
Is C.
the ozone, but basically, I can't see D. D can.
Is C. Moon is between the sun and the earth.
Yes, you said option C. So he said, well, option. Okay, very good. Do we have any other answer? Anybody else? Without wasting our time, the answer is actually C. Because if you look at option A, it says the Earth. Let's say the Earth, this is the Earth, is between the moon and the sun. This is the moon and the sun. What will actually be covered there is the moon. There will be a total and partial eclipse on the moon based on the shadow that is cast by the Earth. So that means basically, like I told you, what is going to block is what is going to determine the name of that eclipse. And in this case, it is actually a lunar eclipse. So option A describes lunar eclipse, which is not our answer. Then this says the sun is between the moon and the earth. That's practically impossible, right? Because the sun does not rotate. The sun is the center of our system. That's why, in fact, our planetary body is called the solar system. It's in the solar system. So the sun is staying put. There's no way the sun can ever come between the moon and the earth. So that's our option C is correct. Very good. Moving on to question 20 says, when the sun and the earth are shown in the diagram above, which is this diagram here, an observer standing at X is in what position? This is an observer's X. What position is that observer standing in? Is it A, the penumbra, and therefore see the partial eclipse? B, the penumbra, and therefore see the total eclipse? C, the umbra, and sees the partial eclipse? D, the umbra, and sees the total eclipse? What do we think is our answer? So where is the observer and what would the observer experience?
A penumbra and sees a partial eclipse.
Okay. We have one input here. What about the others? Are the others here? Where are the rest? Where are you people?
Yes, sir.
Who are those on the floor? Yes, please answer. I've got it from one person. She said option A is in the penumbra and sees a partial eclipse. Who else?
So what number? So which number are we dealing with?
20.
20.
So I say C.
So we have A and C. So A says the penumbra and sees the partial eclipse. C says the umbra and sees the partial eclipse. Okay. So based on what we did yesterday, you say A. Okay. So first of all, before I proceed, what does the umbra describe in an eclipse or a shadow, and what does the penumbra describe in an eclipse or a shadow?
So the umbra is total eclipse. So why the penumbra is partial?
Right? Why the penumbra is partial, right? All right, that's good. So let's analyze the image that is here. We have the sun. So let's draw the sun significantly bigger. We have the sun right here. And then we have the moon, which is smaller. This is the moon. And then we also have the earth, which is significantly bigger than the moon. So let's say this is the earth. Now, analyzing that image, when a ray of light is from the sun, it meets up with the moon. This is our moon. So it meets up with the moon. Now, based on the fact that the moon is opaque, what am I going to have? I am going to have a dark shadow cast by the moon. So let us draw our shadow that is cast by the moon on the earth. So this is dark shadow cast by the moon. And what is this dark shadow called? It is called the Umbra. Now, if you look at it in comparison with the position of this person, the observer standing at X is at what position? Is at the Umbra position. So that means it eliminates option A, it eliminates option B. We're left with option C and option. Now, based on the position of the umbra of the person, which is the umbra, which is the portion of total darkness, what would this person now experience? Would it be a partial eclipse or will it be a total eclipse? Let's see. I think by now it should become clear to us. What would this person experience? Observer X. Partial, total. So we established the fact that the person will experience, the person is standing in the umbra, right? Not the penumbra. Because the penumbra is around this portion. Let's extend that. This other slightly darker portion is called the penumbra. So the observer is not in the penumbra, right? We've established that. So the observer is in the umbra. So what would he experience, or she, or whatever their gender may be? Class, this shouldn't be difficult anymore. What's happening? Hello. Now, based on what we have done, we established the fact that the observer looking at this position on X is in the umbra, not in the penumbra, because the umbra is the dark portion officially the position where this person is standing. That portion which will be cast by the moon on the what? On the earth. Now, I said that eliminates option A and option B because they're both indicating the penumbra and the penumbra. So, which of these options now becomes the answer? Because I believe that now it should be clear. You have option C, which is that the person is standing in the umbra but sees a partial eclipse. The D is that the person is standing in the umbra but sees a total eclipse. So, which of them now becomes the answer?
So where is X located? Is it in the Umbra or penumbra?
Yes, X here. Look at it. Let me zoom into the diagram so you can see it very clearly. See the position of X.
So now it's in the penumbra. That is B. Penumbra and sees a partial eclipse.
All right. You said the person is in the penumbra and sees a partial eclipse. Okay, let me bring my diagram of the Earth closer. Let's analyze that.
So what's the answer?
I don't understand. So I don't understand.
Yeah, what's confusing you? David?
Yes, sir. Sir, I'm just actually.
David?
Yes, sir. So I'm confused. Sir, first of all, sir, what's the answer first?
Hello, David. Can you hear me?
Yes, sir. Yes, I can hear you.
Yes. Yeah, I can hear you now. You said you don't understand. What exactly?
Sir, I don't understand the drawing.
Okay, that's true. I didn't hear what you said. You said you don't what?
I don't understand the drawing.
The drawing, my drawing or the one here? The question.
The one in the question.
Okay, let me redraw. You know, yesterday in the discussion we had, we discussed about
Eclipse, yes, sir.
Right? And I told us about two types of eclipses. Now, look, let's redraw that diagram here. And now let me use the approximate sizes of the objects that are here so that we can be able to get our exact answer. So now this is the sun. The sun is big, of course, bigger. Then we have the moon, significantly smaller, right here. And then we now have the earth, quite bigger than the moon. And looking at the rays that are coming, let me use green for that. Looking at the rays that are coming, this is the ray from the sun.
It's touching
passing through the moon. And then this is another ray from the sun, passing through the moon and hits it up at this point. Now they're asking us that if an observer is standing at X, so from what I am looking at, I would say the approximate distance of X here on our own diagram will be at this point.
Asking us if a what?
Yes, that would be where observer X is standing.
So they're asking us if a what? So I said something. He said they're asking us.
They said if an observer. Yeah, they're asking us if an observer is standing at X, that is at this position of X, what is the observer going to experience? Number one, the observer is where and going to experience what based on the order of the question. There's penumbra, which is where it is, and a partial eclipse, which is what they experience, or is it penumbra and a total eclipse? So that's what we're trying to find out. Where is this observer at X standing at? All right. So I believe that you get that now, right?
Yes, sir.
So let's look at based on the position of the Earth. All right. So based on the size of the moon, this would be its position of a dark shadow. This would be its position of the dark shadow. Let's make it dark. All right. So we have it all. We have it all figured out now. So based on the position of our observer at X, where is the person standing?
The person. Wait, shall I say where is the person? Oh, it's called breaking.
What?
So you said what? Where is the person doing what?
I said based on our diagram and the position of X, where is the observer standing?
Umbra.
Is it in the umbra or penumbra?
It's standing in the penumbra.
I'm so confused. Is that in the umbra or is it in the penumbra?
No, he's standing in the penumbra. He's in the penumbra. So he's standing in the penumbra.
Not the umbra, it's the penumbra.
Yeah, that's what I said. He's standing in the penumbra.
Hearing you.
Yes. So he's standing in the penumbra. Looking at this image and the size of the blow, right? He's standing in the penumbra because he's outside of this region. Contrary to the other one I did, it's outside of this region of total darkness. So as this object now is standing in the penumbra, what would the person experience? Total or partial eclipse?
He will experience partial eclipse. So he experience partial
eclipse. So the person is going to experience what? A partial eclipse. And what answer does that leave with?
And the answer there is it's A.
A.
Penumbra and sees a partial eclipse.
Yes. Yes. Correct. So let's see. We have another one here. Okay, good. Question 9 says, what is the effect of the increase in the size of the hole of a pinhole camera on the image? So what is the effect of the increase in the size of a pinhole camera on its image? Yes, who can tell me? The effect of the size of a pinhole camera. Yesterday we discussed of the effect.
So yesterday we discussed about the effect of is it the effect of what? So
that hole in that pinhole setup. What's the effect? So what is the effect of the increase in the size of the hole of a pinhole camera on the image? I guess it's looking at us now. We're wasting time on this question. I didn't expect us to waste time on it though. It's simple. It's really simple. Or is it that we've not eaten today, this morning yet? However, I'm feeling that we're not as sharp as we used to be. Okay. I said question 9. Okay, I'll write it here. 9 says, what is the effect of the increase in the size of the hole of a pinhole camera on the image? It's what does it do? It gives a blood image, it corrects for chromatic aberration, it magnifies the image, it brings the image to a sharper focus. Okay, we have D. Somebody said D. Who else? The network is what's going on. Could you please repeat what you said? How about others? I think that yes, David, I didn't get you.
No, so I said too much to repeat what you said. I'm asking if it's me.
No. I don't know who was speaking. I think that should be Blessing. She said she was saying something before you got cut off. Okay, David, what's your input to question 9?
Question 9. Effect of
Yes.
Effect of increase in the size of the hole of pinhole camera. I say D. It brings the image into a sharper focus.
It brings the image into a sharper. Okay, that means it's the same with I think Blessing's answer. Okay. All right, but unfortunately the answer is A. Because remember, yesterday I said literally in the name of the setup, it is called a pinhole camera. So that means the hole must be a pin so that little light will enter and you will have a sharp image. You understand? You have a sharp image. But that image will not be bright, it will be dim. Do you remember that? The hole has to be so small. Remember the image of the pinhole, so that as the light is coming inside the hole, it will constrict it, and that's why you now have a smaller image, right? So we saw that is upside down. So that means we have a sharp image, but due to the constriction of the rays, it will be sharp but dim. But here they asked us what will be the effect if the size of the pinhole is increased. So if I should increase the size of the hole, what happens? More light will enter, so it will be bright. It will be bright, but unfortunately, I give us an example of when your phone, all of a sudden you go into sunlight. What happens? It will be blurry.
Wait, am I your phone?
So which one corresponds with them? Yes, I said, like, for example, if you take your camera lens all of a sudden into sunlight, first of all, you are going to get a brief moment of blurry images because so much so much sunlight flooded into your camera lens. And so your camera is now going to regulate, its focal length in order to be able to accommodate the right amount of light and focus properly. I also give us an example of if you wake up and all of a sudden maybe your light is turned on. Maybe you slept with light on, or maybe while you were sleeping the light was not on, and then you just wake up suddenly to that light. First of all, you're going to be a bit puzzled for that light, and then your eye needs to readjust itself in order to get it all right. So that means if you increase the hole of that your pinhole setup, of that your pinhole camera setup, what you're going to have is that the image will be very bright. You have a lot of color in the image, but unfortunately, it will be blurry. So the answer that corresponds to that is option A. Is it?
So I didn't get you.
Is it clear?
Yes, sir.
I said yesterday we dealt with the pinhole camera setup, and I said from the name pinhole, that means the hole in that camera must be small, and that's why you can see a large object. That diagram we drew yesterday. There are so many rays going, but only 2 rays per se would be able to be constricted through that small hole, and that's why on the screen you now have a small image that is inverted, which means upside down, as you can see here, because of this small hole. So if you should increase the hole, light will enter, and you will have a bright image. An image is said to be bright when it is well lit. You understand? When the image is well lit. But due to that flooding of the light, like in the case I gave you with your phone, with your eyes, when you wake up suddenly to bright light, the image will be blurry on the screen. Therefore, the effect of the increase in the size of the hole of that pinhole will give you a bright image that is blurry. But looking at it, they only talk about blurriness. So we're going to go with option A, which indicates that the image will be blurry. Is that not clear?
Okay, yes, sir. Yes, sir.
Are we satisfied?
Sure.
Are we satisfied, class?
Yes, sir.
All right. Let's look at another one. Is there another one that covers what we did yesterday? I don't think so. So that means we would have to. Okay, 16. It says the image in pinhole camera or in a pinhole camera is dash. What is the nature of the image formed in a pinhole camera setup? A, it says it is erect and formed by refraction through a lens. B says it is virtual and formed by dispersion. C says it is erect and gets sharper as the hole gets larger. D, it is inverted and formed by the light from each point traveling in a straight line. So what do we take as our answer for question 16?
So I say D. Option D.
D, right? Very, very straightforward.
D.
Yes, correct. Very, very straightforward. The answer is option D. Yes. Because if you look at the other options, they are just way out of line. A says it is erect. We know that it is not erect. In fact, we just drew the diagram now. It is not erect, so that is out. B says it is virtual. Now, a virtual image, like I said, cannot be captured on a screen. So that means the image cannot be virtual and it is not formed by dispersion. C says it is erect, that disqualifies it, and D says inverted. So basically, that is just the answer. Okay, let's look at another one. We have another one. Non-luminous objects, 29 and 30, and then we'll move on to something different for today. Non-luminous objects can be seen because they are dash. Non-luminous objects can be seen because they dash. A, they are polished. B, they are near. C, they reflect light. D, they emit light.
Where's the person?
What's the answer? Why do we see non-luminous objects?
That's our question was
29. 29.
That's C, they reflect light.
Non-luminous objects,
C,
they reflect light. That's correct. Yes, correct. Then 30. The instrument used by designers to observe or to obtain different color patterns is called dash. A, periscope. Sorry, I'm not saying A.
So the answer is periscope.
Sure?
The answer is periscope.
Are you sure?
That's what I think.
Are you sure?
Yes, sir.
Well, I think maybe because periscope is the most common. Let me draw a periscope for you. Now, if you have watched war movies or if you've watched submarines, like why I said war movies, yes, basically war movies, you will notice like for those people who are inside, what do they call them? Tanks. Those,
yes,
I almost said GP tanks. They will be inside and they'll be observing the enemies outside from under, and then they'll be firing from that tank. Now that image or that object that they're using is called a periscope. So they are not using it to get colors. Instead, they are using it in such a way so that even if you are below the surface, because if you come above the surface, you are going to be in direct confrontation with the enemy and you could get hit by the enemy. So instead, by inverting two mirrors at 45 degrees, there's one mirror here and there's another mirror here. No, like this, sorry. There's another mirror like, let me erase that one so it doesn't create confusion. So there's another mirror here like this. Now what happens is that rays of light from outside will enter into this periscope, hit this mirror, it will be deviated, hit the other mirror, it will be deviated, and then you can be underneath and still see someone who is above, and you can aim and fire. So basically, a periscope is used to have wider range of view when you are underneath the surface. So basically, the answer is not periscope. The answer is actually called a kaleidoscope, and I think that's what we are supposed to start today. A kaleidoscope is an image or is an object rather that is used to obtain different different colors of light when you show it.
Spell it.
K-A-L-E-I-D-O, then S-C-O-P-E, kaleidoscope.
It used to do what?
It is used to obtain different patterns of images. Let me show you. I have an image of it here in my notes.
Okay, sir.
Yes, this is it. This is the kaleidoscope. This is the people, and it has different colored glasses. And so it is now used to obtain different arrangement of color patterns. I won't pick one color patterns. If I go online, you're going to see so many different forms of color patterns that can be formed based on the colors of the glass pieces that are in. There was one that we used to play with them. It was in form of a camera, but it was not really a camera anyways.
Yes, sir.
Kind of arrange pieces.
Pictures inside the camera. You don't snap it and you click it.
Now, just like you said, this is the first way it's this mirror. Now, these two mirrors are inclined at 45 degrees. 45 degrees. So it meets up and is reflected or deviated on this mirror, which gives you a direct line of sight of people who are above. Now, for a kaleidoscope, sometimes the images are inclined at 45 degrees. That's this prism here, this mirror strip here is inclined at 45 degrees, sometimes 60 degrees. So moving on. So today we hopefully finishing on reflection, and I want us to be all set. All right. So today we're looking at plane mirrors, and of course we know what a plane mirror is. Basically, your mirror at home is a plane mirror, except if you use the kind of mirrors in cinemas or so. But basically, our normal mirror that we use to observe our face while we apply makeup for our ladies, while men, do we use mirror? Well, basically, mirrors, whether a lady or a guy, the mirror you use is an example.
So some boys do.
Now, what are the characteristics of images formed by this mirror? Yes, some boys do, yes. In fact, I mean, mirrors are for everybody, right? So, plane mirror. Now, what are the characteristics of images formed? Remember what I said, the virtual image. What I said, a virtual image is.
A virtual image.
Yes.
A virtual image. So did you say a virtual image?
Yes.
A virtual image is something you can see now with your eyes.
Yes, a virtual.
It's something you can see with your eyes.
Are you sure?
Yes, virtual. It's not like your eyes, you can see.
Okay. Okay. All right, you have an idea of it. Now, when we talk about the virtual image in physics, we're talking about an image that cannot be formed on a screen, but it is reflected from behind of the mirror. Like, for example, if you look at your image when you have a mirror, you're standing in front of it, somebody is standing in front of a mirror. Yes. The image here is virtual. It cannot be formed on the screen behind. Are you getting me? But instead, it is reflected off from that mirror. A very good example would be this class now. This class is a virtual class. Are you getting me? It is not formed in your screen of your LED screen of your phone. But instead, what is happening is that the image of this class or this presentation is being reflected off. Are you getting me? The opposite of it will be a real image. Are you getting me? A real image can be captured on a screen. A very good example is a projector, and it can appear before you, right in front of you. That's why, like in this virtual one, it cannot be captured on your screen. That's why the image cannot be brought outside towards you. Like from the word real means something that you can feel. Is that not correct? But that's not the physics definition. I'm just using an illustration that can help you to understand it. Now, if something is real, that means you can really, really see it tangibly. Like I gave us an example, an image formed by your projector is real because that image is directly on you and can be projected on the screen. That's why in those days when we're younger and when teens church, you want to show Passion of Christ because a projector projects a real image. That image can be projected on a white material. You remember, we sit down, they project it on a white material, and then we'll all be watching.
Yes, sir.
Because that image is real and can be projected on the screen. But the image in your phone, for example, is not real, it is virtual. So it can only be reflected off of the image of your phone. Can you project that image to maybe another material in front of your phone? No.
No,
Right?
sir. Yes,
Because
sir.
it is virtual. So that's just basically a simple, very good. So that's a simple way of remembering what it is. But basically, the physics definition of a virtual image is an image that cannot be formed on a screen. Instead, it is reflected off of the screen of whatsoever device you are using. Like if you're using a laptop, you're using a phone, maybe a tablet or Android phone. The image is virtual. And that's the same thing with your mirror. If you are standing before your mirror, can you project the image on your mirror on another material? Let's say a white surface also. It's not possible, right? Because that is virtual. That is virtual. So that's the first characteristic of images formed by a plane mirror. It is virtual, which means cannot, let me edit this. Okay. Which means cannot be projected. Because I'll send this full note for you guys so that it is complete. Cannot be projected on a screen. Instead, it is reflected, what is reflected from behind the mirror. What is reflected from behind the mirror. All right. Okay, that's it. Right.
You should not come here.
Like if I'm standing before my mirror, unlike for example, your mirror, you polish. This is a mirror. Once you see a line and then it is polished on one surface. In fact, basically that's how a mirror is formed. You polish it on one surface. This is how you represent the mirror in physics. So if I should put P before the mirror, because it is laterally inverted, what will I have? I have something like this. Yes, I have something like this. Side to side. Let me show the direction of tilting. And then you tilt it through a degree change. That means, like in this image now, I have M. M is the original position of the mirror. M is, you remember what I said about mirrors? To signify mirrors, we show a line and then we show where they are polished at the back in order to capture images in the front. Okay? Now, if you tilt it through an angular change, if you tilt it through an angular change, like in this direction, I take this way and I tilt it, let's say the angular change is theta. Now, initially, first of all, let me draw my normal. You know, I told you, for every mirror equation we are solving, we must draw a normal. Okay, that normal is an imaginary line. So let me draw my normal here. So you can understand what that image is and how it came about. So this is my normal. Let me call it normal 1, N1. Now, the angle of incidence is going to be equal to the angle of reflection. So let's draw the angle of incidence. So this is the angle of incidence. Here is the incident angle. Let me call it theta. Let's say that normal line is around here, because for every mirror, remember what I said, you must have a normal line. So let's draw its own normal line. So this is its own normal line. This is not capturing what I need. All right. So this is the new normal based on the new position of the mirror. Please, I hope you are following me before the image gets complicated. Did you get this first illustration? This is your mirror at the initial position, which I called M. This is the normal line. An angle of incidence is equal to the angle of what? Of reflection. Now, when you tilt it upwards, now when you tilt it upwards through an angular change, that means there's a new normal line to be drawn. You can call it N1, since right N, I can call it N0, whatever. So let me call it N1. So now what will happen is that there will not be a new angle of incidence. Am I correct? There will be a new angle of what? Of incidence for this new position of the mirror. Let me use this word here. So this was the initial normal line which I've showed us. There's an angle of incidence I, which is equal to the angle of reflection here, which is R. Now, based on the new position, there's a new normal line, and there will be an angular degree change, which is theta. So that means the new angle of incidence will be in proportion to the angle to which it was tilted. So that means the new angle of incidence here will be theta. And so that means if the new angle of incidence here is theta, which is equal to the degree change, because remember, a plane mirror is like you do me, I do you. If you are coming towards me and I have a clearer image of you, I will produce a bigger image of you as the size is to me. If you are walking away from me, what will happen? Your image size is becoming smaller. I will produce a smaller image. So if you also tilt it through an angle of theta, that means the angle of incidence here will also be in the same manner, which is what? Theta. And so this is the new angle of incidence, theta. And it will now have a new angle of what? Reflection. Remember, from the second law of reflection, angle of incidence is equal to angle of what? Reflection. So that means the new angle of reflection also will be what? Will be theta. So if we check it, what will now be the total image that is being formed? Or what will be the total angle through which was the image that is being formed will be rotated through? It will be, initial one was theta 1, which was the angle of incidence plus this angle theta. An angle of incidence here is equal to angle of reflection here for the first normal, this normal line. For the second one, tilting it through theta will make the new angle of incidence to be theta, which will be equal to the angle of reflection according to the law, which is also theta. So for here, theta 1, which is the angle of incidence normally, will be equal to theta r here. So let me call this theta r here. And so what will now be the total new angle of the reflected ray? It will be theta plus this theta 1 here. Of which, remember what I said, basically, in layman terms, a plane mirror is what do me and I do you. What you do to the mirror is what the mirror brings out to you. So this angle of incidence is equal to the angle of reflection here. So that means the total angle of incidence here now will be initial angle of incidence, which is theta 1, plus initial angle of what? Plus the second angle of incidence when you rotated the mirror, which will be theta plus theta I. And then, according to the law of reflection, angle of incidence will be equal to angle of reflection. So that means the angle of reflection also will be what? Theta plus theta I. Therefore, since the angular change in a mirror is proportional, right? if the angular change in the mirror is proportional, because remember what I said? I said a plane mirror in layman terms is what a do me and I do you mirror. That means this new angle of reflection will be theta plus theta I, which would be proportional to the angular change through which it was rotated. So that means we can basically say that this one also will be equal to theta based on the proportion. So the total angle of reflection will be theta plus theta, which is what? 2 theta. But basically, the concept for you to understand is if you rotate a mirror through any angular change, the image will be reflected through twice of that angular change. And what is the reason? From here, you have an angle of incidence which will be equal to the initial angle of reflection. Then for the second point, when you reflected it, you see how that angular change here reflected as the new angle of incidence, which will be equal to the new angle of reflection. And in total, if you check from the normal line here, this normal line, what is the total angle through which what this image will be reflected? It is the theta, which is proportional to this image, plus theta, which is 2 theta. Do you get me?
Yes, sir.
Yes, sir.
All right. So the concept of it is that
Yes, sir.
whenever an image, or not an image, sorry, whenever a mirror is rotated, all right, yes, thank you. So whenever a mirror is rotated, due to the law of reflection is being obeyed, theta 1 equals to theta 2, new angular change theta will also be the other angle of reflection. So,
Down.
so the total angle of reflection here will be what? What?
So please scroll up.
Is this okay?
Thank you.
Like towards the image, this one. All right. So, all right. Now the next thing we have to look at, let me give an opportunity to write. Now the next thing we have to look at is the formula for number of images formed by a mirror when two mirrors are inclined. You know, sometimes there are cases based on the fact that a plane mirror is the simplest type of mirror that you have. In order to have more images, you cannot use one single mirror. So what we have to do is we have to combine a series of mirrors in order to be able to get different kinds of images that we need. Let me explain what I mean. For example, in a barber shop, you need to have a view, or at least 2 views. Are you getting me? At least 2 views of the person that is having his or her haircut. You understand me? So if you use one plain mirror, you are not going to have the number of images that you need. That's why most times, though a way to balance it, most barber shops don't follow that. So just avoid stress. They'll just place one mirror in front of you and one mirror behind you. That's just a simple way of just giving you number of images. But sometimes, in order to create a form of experience, you can need to incline mirrors to themselves, because a single mirror in itself will just give you one image. So the formula for number of images formed by a plane mirror, are you there? So the formula for number of images formed by a plane mirror is given by 360 over theta minus 1. All right. So the formula for number of images formed by a plane mirror is given by 360 over theta minus 1. 360 over theta, then minus 1. So this is the formula for number of images formed when 2 mirrors are inclined. What do you mean by inclined? For example, if I have one mirror here and I have another mirror here, they are inclined to each other at 90 degrees. But I have to indicate that they are mirrors by indicating their coating. So let me indicate their coating. Now, so that means since these 2 mirrors are inclined at 90 degrees, the angle between them is 90. So we have 360 over, what is the angle between them? 90 minus 1. That's what will give me the number of images that will be formed. So 90 here should be 4. 4 minus 1 is what? 3. So you can see, each mirror here will give me one image. Are you getting me? One on its own will give me one image. One on its own will give me one image, but by inclining them together, I get more images. So that's the goal of inclining mirrors, so that you can maximize the mirrors that you have. You get it? That means, for example, also, if they are inclined at 60 degrees, how many images will be formed? Who can tell me? If the two mirrors are inclined at, say, 60 degrees, how many images will be formed? How many?
So please, what's your question?
I said, if two plane mirrors are inclined at 60 degrees, how many images will be formed?
Would it be 3?
Who can tell me?
Would it be 3?
Would it be 3? Let's see. Now, if the images between them is 60, let's see. No, it should be 5. Because according to the formula that we have for number of images formed by plane mirror, it is given by 360 over theta minus 1. So that means the angle between them, like in this case, was 90. That means theta is 90. But I said, if they are inclined at 60, it will be 60 years, 6 minus 1, 5. So you can see with just two mirrors, which normally should produce 2 images. You can have 3, you can have 5, you can even have 11, you can even have infinity. Now let me give us a question here. I'm holding the past question here. Now just listen attentively, please, because I don't have it typed out. It says, 2 mirrors are inclined. I would like us to attempt this. It says, 2 mirrors are inclined to each other such that the object placed between them has 11 images. So that means the number of images produced are 11 images. Please take note. Two mirrors are inclined such a way that the object placed between them has 11 images. Determine the angle of inclination, which is theta. What is this? This is WAEC 2018 question 23. The 2 images are inclined to each other such that an object placed between them has 11 images. Determine the angle of inclination. If you have an answer, please let me know. What is the angle of inclination? Okay, let me give you options. This is an objective question. I think it would be fair to give you the options. We have 30 degrees, 45 degrees, 60 and 90. So let me read the question again, in case anybody didn't get it. The question is a WAEC question from 2018 objective number 23. It said, 2 plane mirrors are inclined to each other such that an object placed between them has 11 images. Determine the angle of inclination. So we're looking for theta. So who has the answer, please? Or do I solve it and give you the next one?
Yes, sir. Is it for each of them? Is it this 30 degrees, 45 degrees? Is it for each of them?
No, you know, the angle is for both of them. Remember the first image I drew? Look at these 2 angles. This is a mirror on its own. This is a mirror on its own. Whatever angle that they are inclined is for both of them to each other. So if they are inclined at 60 degrees, that's the angle between the both of them. And I showed you the reason why. Like, for example, in this case, when they were inclined at 90 degrees, each of them normally, this mirror on its own will produce one image. This mirror on its own will produce one image. But by inclining them at 90, I was able to get 3 images. I was able to get 5 images. So the purpose is increasing or maximizing whatever amount of mirrors that you have. But instead of just having 2, you can incline them at whatever angle to have a wider number of images as you need. So the angle is for the both of them. Or do I solve this one and then you try the next one?
So you say we should solve it. I think we should solve it.
Yes. Yes.
Okay, so the first one, that is 30 degrees. The answer will be 11 images.
Okay. No. I think you mixed up the question. Let me read. Okay, you have actually the question, but you mixed up what I asked for. I said that we have 2 images. We have 2 mirrors that are inclined in a way that they produce 11 images. Then they now said find the angle of inclination. They did not say find the images produced under each angle of inclination. These are the options. This one is option A, option B, option C, and option D. So you are correct. The answer is 30 degrees. Now let's solve. The number of images formed is equal to 360 over theta minus 1. So number of images formed, as they told us, we have 11 images. So 11 images formed. So they now told us to look for the angle that they are both inclined to each other at. So I have 360 over whatever the angle of inclination is, which I don't know. I call it theta minus 1. So when minus 1 moves over to this point, I have 11 plus 1, which is 12. 12 is equal to 360 over theta, and then cross multiplying 12 times theta.
Hello, sir. Hello, sir.
Is equal. Yes, sir.
Yes, sir. I would suggest we'll be doing an engagement of every child in this class. We're not just doing a class, just a low-mind class. We want a situation where every child participates, even when a question is asked. Whatever we achieve, no matter how small it is, we're sure that every child are on one page. Because I just came in. I discovered that specifically, I take it with a point of reference from Innocent. He is not solving. He's not solving. How will he? So every child must show his anything, because there are not many. We're dealing with a few students. Every child must show his working.
Okay.
I don't know if it's even possible.
Okay.
The stop and snap and forward. It shows participation. And participation will make everybody to be engaged. Taking from my own point of view. Thank you.
All right, sir. Yeah. All right, no problem. Thank you, sir. No problem, sir. Thank you, sir. All right, so moving on. To get the angle of inclination, I have to divide both sides by 12, of which, what does that give me? That gives me 30 degrees. That gives me 30 degrees. So let's take a fast question on that. So like I said, anytime we finish a topic, we'll be taking from JAMB and other exam bodies. So let's take one from JAMB. So we'll be solving it. So basically, in my own opinion, any question on number of images formed, I think it's just too easy. So I think you should be able to get every question on number of images formed when 2 mirrors are. Okay, let's do question 13. Question 13 says the plane mirror in a kaleidoscope are inclined. The plane mirror in a kaleidoscope are usually placed in dash, or usually placed at what angle to each other? I made mention of that briefly, though I didn't write it in the note. Who can tell us? The plane mirrors in a kaleidoscope are usually placed at what angles to each other?
So which number? So which number is it?
Number 13, 1 3.
So number 13, C.
What angle? For a kaleidoscope, no. It can't be C, because if you look at the image of a kaleidoscope, let's get the image back again. If you look at the image of a kaleidoscope, there's no way the angles would be the mirrors would be inclined at 90 degrees, because you need that balance inside the instrument to be able to produce those wide range of like look at for example, when it was 90 degrees, it produced 3 images. When it was, for example, 60 degrees, it produced more images. So that means you need to aim for a lower angle. But anyways, not to waste our time, this is specifically saying the angle is 30 degrees. This scope is placed at 60 degrees. This angle at 60 degrees. I hope that's clear. Do we get that? Do we get it? Hello?
Yes, sir.
Hello? Alright. So let's take an image.
Yes, sir.
Image formation question. Okay, this number 2 is basically a bit out of line from what I thought, so I'll solve it myself. Then I'll look for other ones. Now, this number 2 says, a man standing between 2 parallel mirrors in a barber shop, we see the following number of image. Now, number of image is equal to 360 over theta, right? Now, parallel mirrors, the 2 mirrors are parallel. These are 2 mirrors parallel. What is the angle between them? Who can tell me? Who can tell me? If I have 2 mirrors that are parallel, what will be the angle between them? The angle will be 0. You know why? Because they are not inclined to each other at all. So the angle will be 0. That's why I said this one is a bit out of tune from what we discussed. So that's why I'm solving it myself. So that means, the formula is theta over 360 minus 1. 360 over theta minus 1. And so since the angle here is 0, now when you divide by 0, what will you have? Who can tell me? Yeah, I don't know if you experience that. When you divide the number by 0, your calculator will give you math error. But what's the actual value? The actual value is infinity. When you divide by 0, you have infinity. You know why? Let me give you the concept of division. For example, if I have 4 divided by 2, let me go back to our primary school. You have 4, 1, 2, 3, 4. Divided by 2 means you are sharing it in 2s. So I have 1, 2, I count 1, 1, 2, I count 1. So that means in total, how many pairs do I have? 1 and 2. That's why 4 divided by 2 is what? Is 2. Now when you now say 360 divided by, or any number divided by 0, if I have, for example, 2, divided by 0 means I'm sharing it 0, 0, which means I'm sharing it nothing. That means you can share an infinite number of nothing. I don't know if you get me, because the concept of 0 is a very funny number. Now that means since you are dividing by 0, remember, like here you're dividing by 2, that means you are sharing it to everybody there. There are 4 people there. You are sharing whatever that they have in 2s, right? Maybe you have 4, and you are dividing it into 2. So that means you can only give away to 2 people. But if you have something like 4, and you are dividing by 0, which means you are sharing it nothing. Oh my God. So did you get what I meant by dividing the number by 0 gives you infinity? Do we understand that brief illustration? Class, we understand that brief illustration?
So please, can you explain it again?
Hello? Okay, now let me explain it again. Now, in your normal division, for example, if I say 4 divided by 2, that means I have 4 packages and I'm dividing it into 2, which means I'm sharing it 2. So I wrote it 1, 2, 3, 4. That means I'm sharing it in 1, 2. That's one package. 1, 2. That's one package. So how many people in total can I share 4 packages to? If I'm sharing them in 2s, I can only share to 2 people. So that's why 4 divided by 2 is 2. Now let's now take the same scenario. 4 divided by 0, which means I'm sharing it in zeros. Basically, though 0 is not nothing anyway, but in layman understanding, 0 is nothing. That is, if I have 4 parcels or 4 biscuits or 4 whatever, and I'm sharing them in zeros, that means I'm taking nothing out of them. How many can I share? I can share 1 billion because I'm not giving out anything. I'm sharing by 0. You understand? Like if I'm sharing by 2, I'll take it 2. If I'm sharing by 0, I'm taking nothing. I can share 1 billion. I can share 2 million of it. I can share 3 million of it because it is basically nothing that I'm giving out. So that means I can share it to an infinite amount of people. You understand that concept?
Yes, sir.
Yes, sir.
All right. So you will now have 360 divided by, since they are parallel, that means the angle between them is 0. So 360 divided by 0 is infinity because when you divide by 0, you can share it to many people. So many people, because basically 0 is nothing. So I can give it to anybody I like. So infinity. So when you have infinity, which is the amount of zeros you can share basically. So you have infinity minus 1. So that means the number of images will be, now, let me see. If you say infinity minus 1, what would you have? Who can try? Just try, okay? That's actually myself, because it's a bit abstract. I believe that for prospective ones, with this example, you'll be able to do this work yourself. So what do you think? If I subtract 1 from infinity, what will be my answer? I just need someone to try. Well. It will be what? It will still be infinity. Okay? So that will always have time. It will still be infinity. You know what? Now the concept of infinity means endless. Even if you do infinity minus 1 period, it will still be infinity. Do you understand? If you say infinity minus 300 trillion, it will still be infinity. Because infinity is endless. So there's nothing you can take from it that will dim it. Do you understand what I just said? Do you? All right. So that's why infinity minus 1 is infinity. So that means the number of images for the infinity. So our answer there. What question was I coming? Question 2, right? I said the man standing between 2 parallel mirrors in the barber shop will see the following number of images. How many? The answer is E, infinite. So the answer is E, infinite. So from this now, I believe you can be able to solve any other question on mirrors that are inclined at a particular angle towards each other. Let me see if I can find one more. Okay, let's do 17. So it's the word problem, but we've done it. It says when, let me write it down in case you're not seeing what I'm pointing out. 17, question 17. This is question 17. When a linear at which a ray is incident is rotated through an angle Q, the reflected ray will be rotated through what angular change? Who can tell me? Someone should try. This one is easy. When a plane mirror at which a ray is incident is rotated through an angle Q, the reflected ray will be rotated through dash. We have A, half Q. That's question 17, please. We have B, Q. We have C, 2Q. We have D, 3Q. Someone should help us. I'm waiting. We just dealt with it, the subtopic before this one. It's somewhere here. And children, are you there? And we again,
Yes,
right? Good now. That's questions, right? Are we all here?
Yes,
Okay.
sir.
So what do you think the answer will be for question 17? Where is David? David is not here.
Samuel.
Hello?
Samuel.
Okay. So we're asking, I was asking the question. 17. Okay. Wait again. In fact, if you are here, just raise your hand. Let me know the people that are in the class, because I'm not getting response. Like yesterday, we were very lively. Today, I'm not feeling on. What's going on? Please, if you are here, just indicate, like, if I unmute them, I can say your name, because I'm not on the Google Meet app, so I won't see you. You raise your hand. Just unmute your mic and indicate that you are present by just clicking. If you are present, I, David, I, Chairman, I, this are present. Just indicate. So that means I'm not following, because I just said something now. I think if you are present, please unmute your mic and just indicate I, and maybe I, choose about present. Let me know how many friends are.
Yeah.
Yes. Is there? Who?
Innocent.
Who is the person that just indicated that is here? Okay, Innocent is here. Okay, Innocent is here. Who again is here?
Sir David is here.
Sammy.
Sir
Is there
Precious.
Innocent that is here? Okay.
Sir Goodness
David
is
is
here.
here. Who is me? Miss Me. Okay, question
Sir
is here.
Goodness.
That is only three. Goodness is here. Okay, so I have 4 people: Precious, Goodness, David, and sorry, I missed it. And Innocent.
Yes, sir. Yes, sir. Mention the names again.
Where is the other? I said David, Precious, Ugonna, Innocent. Who else?
Okay, I'm not here again. Hi.
Who else is here? So that means I only have these 4 people.
So I don't even mention my
God bless
name.
you.
Yes.
Okay, I didn't know now. I said, okay, good. I said, if you are present, please indicate. You did not indicate, so I didn't know, because I'm not on the Google Meet app. Okay, so that means we have Blessing here. That is 5 people. Let me call again. We have David, we have Innocent, we have Precious, we have Goodness, and we have Blessing. I think all the people present.
Yes, sir. Yes,
Okay.
sir.
So, question 17. I was asking us to solve question 17. All right, very good. So please let's follow through, because our time is almost up, but we need to cover. Now, question 17 says, when a plane mirror at which a ray incident is rotated through an angle Q, the reflected ray will be rotated through dash A, half Q, B, Q, C, 2Q, D, 3Q. What's the answer to 17? Basically, I'm not you don't understand what I thought earlier. What's the answer?
I'm not hearing you. Your call is breaking. So I'm not hearing you. Your call is breaking.
Okay. How about now?
Yes, sir. So I repeat what you said.
Okay. So I was asking us to solve question 17. I said, question 17 says, when a plane mirror at which a ray is incident is rotated through an angle Q, the reflected ray will be rotated through what angle? Is it A, half of Q, B, Q, C, 2Q, D, 3Q? What will be its reflected ray, the angle in which the reflected ray will be rotated?
Sir, 17 answer is B.
Okay. So that means if it is rotated through Q, you are saying it will be reflected through Q again. Is there any conflicting answer before I give the correct answer? Any conflicting answer? Or are we all in unison? Are we all in unison? Okay, now, remember what I said. I said if the mirror is rotated through theta, the reflected ray will be rotated through theta. Now this one, they just made it work for the rest of including angles. They now said the mirror is rotated through Q. What will the reflected ray be rotated through? 2Q. So the answer is actually C, 2Q. Do we understand?
Yes, sir.
Do we understand?
Yes, sir.
All right. So, all right. Now, please, let's solve 21. Let's solve 21. An object is placed in front of two plane mirrors inclined at an angle theta. If the total number of images formed is 7, find the value of theta. So this should be easy. It should be found. I hope we heard me first. Let me be sure that we are currently solving. Did you hear the question I asked us to solve? Or let me go to the new page and write it. We are solving 21. Please, you are attempting 21. 21. 21. Please, who is solving? Indicate. Let me know. If you are solving, indicate. Hello?
Yes, sir.
Okay. Please, when you have the answer, let me know.
So is it 45 degrees? B. B, 45 degrees.
Okay. She has 45 degrees. I think that should be. Wait, let me know. Okay. Let me see if there will be another entry. So let me note your answer. You said B, 45 degrees. Yes, 45 degrees. Noted. Thank you very much. 45 degrees B.
That's 45 degree.
David,
Sir, goodness.
Ugono.
Yes, sir.
Innocent. What are answers? Oh wait, were you in the class when I taught that particular subtopic? Number of images formed by mirror. Were you in the class?
Yes, sir.
Okay, so that means you'll be able to attempt it. All right. So what's your answer, please? I'm waiting for you specifically now.
I see nothing.
That's a dream man class.
Innocent, what's your own answer? Innocent?
Yes, sir.
Innocent. What's your own answer? Are you solving?
Yes, sir.
David, I've not heard from you. So that means I can believe that David is not in class, or David has not to it. Okay, was active before, probably something. All right. Yes, the person of
So it's the answer 45.
The answer is 45.
It's at 45 degrees.
okay. So an image is placed in front of two mirrors, inclined at an angle theta. This form is 7. The number of images formed is given by 360 over theta 1. Are we following? So the now told us that the number of images formed is 7. So the number of images formed is 7 is equal to 360 over theta minus 1. So
it's 8 minus 1 equal to 7.
We have 8. No, it is 7 plus 1. This is minus 1. Crossing over to the other side. So it becomes plus 1. So it's 7 plus 1, which is 8, is now equal to 360 over theta. So when you cross multiply, you have 8 theta is equal to 360. And dividing both sides by 8, while the calculator help us, that should give you 45. You can do it manually. So here, 2 here, 180, 2 here, 2 here, 90. Then 90 divided by 2 is 180. So theta is actually, 90 divided by 2 is 45, not 180, sorry. So theta is actually 45 degrees. Alright. Okay, good. So you should be formed. 22 is formed. Let's do 22. Now 22 is formed because the reason why most people used to have issues in JAMB or fail JAMB is not, sometimes not really that they are not intelligent, by the way, because I've seen even people who are intelligent miss one or two, because sometimes, just like the way I taught you mirror formula, and now coming to this place now, we now solve, I think that was number 2. Let me look for that question. Number 2, yes, number 2, we now saw parallel mirrors. So you are able to, associate parallel with 2 parallel lines and not explain so that the angle is 0 degrees. Such a person will know the formula and not be able to solve it. So sometimes it's not just about what you are talking to, it's about your analytical skills. So that's why I want us to actually attend to the two. Because let's say, and I'm not really talking of the 22, but it's not like it's a topic to be taught. I don't know if you understand me. It is something that based on what I've discussed, you are now going to analyze and then get the answer. Now let me show you what I mean. I'm actually going to solve it so I don't waste time on it because it's not really a cliche question that you can say, okay, based on this topic, this is what I'm solving. It's just about based on what you've learned now on reflection, they are expecting you to analyze. Are we going to get what I mean now? By
Yes, sir.
analytical skills. Do you get me? All right. Now look at this question now. It says a man stands 4 meters in front of a plane mirror. It may look like, oh, sir, you've not thought of it, but I actually have. But just like I said, sometimes it will not be straightforward. They would test your analytical skills. So that's what they are doing. So watch it. Now, so the man stands 4 meters in front of a plane mirror. Let me go to the plane mirror. Let's say this is the plane mirror. Remember, to show you that it's a mirror, you show us all these surfaces. I'm not even doing it right, but because of my mouse right now functioning. But if you understand what I'm trying to do here, trying to show us that the back is polished. Alright. Now there's a man standing 4 meters in front of it. So this is the man standing 4 meters in front of it. So let's draw. The distance between the man and the mirror is 4 meters. Then the now told us, please, I'm solving 22 in case you might ask what question is this solving. Please, is everybody clean? Because this question is different, so I need everybody to be on the same page with me. Are we together with me? Everybody? Are we together?
Yes, sir.
Yes, sir.
Are we together? All right.
Yes, sir.
Okay, 2. All right, good. So now the map is 4 meters in front. Okay, very good. So the map is 4 meters in front of the mirror. Now the man told us that if the mirror is moved 1 meter towards the man, so that means this mirror now was moved forward by 1 meter. So let's say this is the new position of the mirror. Let me use the green marker. So this is the new position of the mirror. The mirror is in front, and then now the distance now was what 1 meter. So it was moved forward by 1 meter. So who can tell me what will be the distance now between the man and the mirror, first of all? Because now let me finish up the question. Then I ask if the mirror is 1 meter towards the man, the distance between him and his image is dashed. So it's the distance between him and his image. So like I said, remember, it may look like, oh, our teacher didn't teach us this, but it's more of like, did you really understand what the teacher said? And so can you analyze it in a practical problem? So remember what I told you about images formed by a plane mirror. I said it is same distance. The image on the mirror is the same distance as the object is from the mirror. Do you remember that? That's why I gave the example of if you are walking farther away from the mirror, the image will be getting smaller and smaller. Now, what will be the mass distance now from the mirror since the mirror was moved forward by 1 meter? Who can tell me? What will be the distance of the man that was initially, the man was here, let's draw him. Standing here, 4 meters. Then the mirror was moved forward by 1 meter. So here's the mirror moved forward by 1 meter. What is the distance between the man and the mirror? What is the distance between the man and the mirror? Who can tell me? Who can tell me? Who can tell me, please?
So please, what's the question? Sorry, I'm not hearing you well.
Wow. I said, yeah, Simon. Now I said, let me read the question again. The question says, a man stands 4 meters in front of the plane mirror. Question 22. A man stands 4 meters in front of the flame. So initially I drew the man, and this was where the mirror was. It was 4 meters in front of the flame mirror. They were not told that if the mirror is moved 1 meter towards the man, now this was the mirror, it was now moved 1 meter towards the man. The distance between him and his image is that. So I need the distance between the man and the image that will be formed. But first of all, I asked us the question. I said, what is now the... Hello? Am I having a problem? I'm still in the problem. Yeah, so that's it. What's the problem? Is it difficult for us to analyze? I'm not getting a response. We're not like this yesterday. What happened? What's happening? What's happening?
Sir, the network here is disturbing me.
What's happening now?
Sammy, to the network.
Okay, network is disturbing you, David. How about you, Blessing?
So my network is fine.
Oh my God.
I'm hearing you well.
It's just disturbing
I'm not
our
hearing you well.
Okay.
Sir, like your call is breaking.
Okay. Can you now hear me? So we can now analyze this question. Hello? Hello?
So I can hear you now.
I can hear you.
Hello? Okay. Is there anybody that can hear me clearly, please? Is there anybody that can hear me?
So I can hear you clearly, but I can hear you, but it's not that clear.
Anybody that can hear me, please?
Not clear.
Our hearing was not clear.
Me too.
It's clear.
What then is the problem? What then is the problem? I think probably that's it. Okay, let me look. Okay, one person is getting it clearly, the others are not getting it clearly. Okay, let me log out and then let me know if it's from my end. But if I want to make, I don't think it's from my end. To be safe, I'll log out now. Okay, I'll log out.
Okay. Yeah, I think he will log in back. Let's make the class more intellectual, more engaging, more participatory. We're in a mission, for sure, for real. We don't want people who do not join us to mock us. They can't mock us by the grace of God.
Amen.
You can't say, see them now. We say that they do holiday lesson. No! Can't be so. Can't be so. There must be something to redefine you, something to single you out. You are a role model. The world shall hear of you. That has been my prayer expectation. Thank you.
Amen.
All right, so those that are experiencing network issues, is it now clear? Can you now hear me clearly?
Yes, sir.
Okay. Okay. So let's go back to the question we're analyzing. All right. So let's go back to the question that we're analyzing. So like I said, most times, while some people have issues with some questions in JAMB, it's not like they were not taught, but it's that probably that analytical aspect was not given to them. So like, if you look at this question that I'm solving now, question 22, it may look like, oh, sir, you point, it was 4 meters away. Then they now told us that the mirror, if the mirror is moved 1 meter towards the man, so this is the mirror, move a distance of 1 meter towards the man. So I was asking us the question, I said, what is the new distance? Exactly, good. I think it was the network that was holding us back. So it will be 3 meters. The man will be 3 meters away from the mirror. So that means the distance between the man and the mirror, the distance between the man and the mirror will be what? Will be 3 meters. Correct, very, very correct. So let's indicate that here. 3 meters. Now, if you notice, that 3 meters is among the options. But what they asked us is the distance between him and the image. What will be the distance between him and the image? Now, like I said I've taught us this. Now, let's prove that we have done this actually. Now, I told us that one of the characteristics of a plane mirror is that the way the object is before the mirror is the same way the image is going to appear in the mirror. Is that correct? That's when I give an
Yes, sir.
That's when I give an example of if you are closer to the mirror, it has your full structure, the image will be large. If you are further from the mirror, it's having a little of your details, that means you are appearing smaller, the image will be small. So that means if you are 3 meters from the mirror, what will be the distance of your image from the mirror? It will be what? Who can guess?
Sir, 3M.
Correct. It will be 3 meters from the mirror. Now, can we now answer the question that says, what is the distance between the man and his image? Who can give me the answer?
3 meters. 3 meters.
You are falling for the trap, or you are falling for the trap. That was the trap that initially they were expecting. The answer is not true. Class, are you getting me? Hello, class.
Hello, Mr. Chike. We couldn't hear you for like 2 or 3 seconds. So you can repeat.
Okay, let me repeat myself. Okay. Now I said that 3 meters that they said here is a trap. And if you said 3 meters, that means you're falling for it. Now, what they actually ask is, what is the distance between him, which is the man, and his image? Now, for what you said, which is correct, by the way, all right? So I'm not,
like 6 meters.
Exactly. So that's the correct answer. So if the man is now 3 meters from the mirror, and according to what I said, the distance between you and the mirror is the same distance between the mirror and the image. And so the image is now also 3 meters from the mirror. So to solve the question, you are not going to pick 3 meters as the answer. The distance between him and his image will now be 3 to the mirror, 3 to the image, which will be what? 6 meters.
6.
So exactly. So when you are solving questions, you have to be very, very careful of those kinds of traps that may be set, especially JAMB. That's where you see those kinds of questions being set. Now, another one, again, that is like that, another very tricky question that may look as though probably you were not on that topic is this one, this next one. That is question 23. Let me go to a new page. Question 23. Now, watch the question. The question says that an engineer intends to deviate a light ray from its path 120 degrees through reflection from a plane mirror. Calculate the angle of incidence. Now, like I said, looking at it, it may look like, oh, we've not really solved the question like that. But from all our discussion, we have. Now, let me show you the plane. It says that an engineer intends to deviate a light ray from its path 120 degrees through what? Through reflection. Then after calculate the angle of incidence. Now, this is the visualization of it. That means a ray of light is coming. This is the ray of light. Let me use dots. A ray of light is coming. Normally, it's supposed to, let me draw my normal line. Let me use green for my normal. And that one will be clearly outlined. So this is my normal line. That means normally it's supposed to strike this surface and then come out, right, as a reflected ray. Are you following? Normally, do you understand before I go too far, please? Normally, it's supposed to come through this angle of incidence, hit with the surface, and come up as a reflected ray. Are you following me? Are you following me? Are we together? Are we together, class?
Yes, sir.
Are we together, class?
Yes, sir.
Yes, sir.
All right. So now, they said that an engineer intends to deviate a light ray from its path from its path 120 degrees through reflection. That is normally this ray of light is supposed to come, hit the surface, and get reflected off. Calculate the angle of incidence. Now, how are we going to solve this? We're going to solve this from our understanding of the laws of reflection. Now, from the law of reflection, if the angle of incidence is x, what will be the angle of reflection? Class, if the angle of incidence is x, what will be the angle of reflection? Can you hear me? Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay. I think you are having
Yes, sir.
Yes, sir.
Okay. Now, it says, if the angle of incidence of this ray that the engineer intends to deviate through 120 degrees, if the angle of incidence is x, what will be the angle of reflection?
degree.
No. You are going ahead
6
to solve.
degrees.
No, sometimes. No, you're going ahead to solve. You're going ahead to solve.
30 degrees.
The answer will be x. Oh, don't solve yet. By solve, you're even complicating the problem. The answer, first of all, is x. Now, how? From the second law of reflection, that's why I said most times this question will just, make you to think off course from what you're supposed to do. Because normally, I believe all of us here were in the class when I taught the laws of reflection. The second law of reflection is that the angle of incidence is equal to the angle of reflection. Is that correct? So I now said, if the angle of incidence is x, what will be the angle of reflection? Also x. So because of panic and the question looks different from what we have solved, you may want to now start calculating, which will now deviate you from the normal course you're supposed to take. But do you understand now? I hope we are now on track.
Sir, please repeat.
I said that from our discussion on the laws of reflection, because here we're talking about an engineer intend to debate a light, and he mentioned reflection. The second law of reflection states that the angle of incidence is equal to the angle of reflection. So I now said this ray of light that this engineer intends to deviate off his normal course by 120. If its angle of incidence is x, what would be its angle of reflection? It will also be x. Is that correct? Do we get that first before I move on?
Yes, sir.
All right, good. So the purpose of this question was to throw you off balance so that it's not a conventional question, so that you can now begin to panic and then leave what you're supposed to do. So first of all, before you start calculating, just get that first. And that's why I told you any question involving reflection or plane mirror, first draw your normal. This is what I did here. This is my normal. First draw your normal and use it as a plane of reference. So the light was supposed to come, be incident on the surface, and then reflect up. But the engineer plans to deviate to that, he intends to make this light go up by an angle of 120 degrees. So first of all, they now told us to find the angle of incidence. And then I decided to name the angle of incidence X. And then I was asking what will be the angle of reflection? It's also the X by the second law of what? Reflection. Now, how can I now get the angle of incidence? By now, I believe that the answer should become clearer. Because if you look at this, if I'm to connect this using thick lines, let me thick lines, you will notice that this is a straight line. Is anybody noticing that?
So I'm not seeing your screen.
Do you notice that? Why is that?